Today we'll learn to draw resonance structures. So for this first example, we have a ring and some pi bonds and the carbocation. Now this approach I'm going to do applies for carbocations and radicals. They work the same way. So essentially your pi bond, your double bond, will want to attack the space where the carbocation was. So the alkene's gonna replace the spot where the carbocation was, and the carbocation, the plus sign, is going to replace wherever the double bond used to be. So that would be this spot. It would not be on this spot because here there's actually no change in terms of the number of bonds that there are. So it would just replace wherever the pi bond used to be. And make sure that you have a conservation of charges. So if we started with one positive charge, all the resonance structures should only have one positive charge as well. So then, especially for rings, you basically keep repeating this process until you kind of accomplish an entire circle. So we've already attacked the alkene to the carbocation this way, this direction. So we're going to keep going in this direction, right? Because if you go in this direction, you're going to go back to this first structure. And the plus sign replaces where the alkene once was. And now we find that there is no other nearby alkenes to the carbocation, so that's all the resonance structures we have. You cannot just bring this here. The pi bonds can only shift one position at a time, so it can only shift to its neighbors one at a time. So once again, this applies for radicals as well. This doesn't have to be a plus sign. This could be a radical, this could be a radical, and this could be a radical. So it would work the same way. Okay, now we have this other problem. We need to draw a resonance structure for this. So here is where I talk about how to make a charge separation resonance structure. So of course you always want zero formal charges, but sometimes if you do want to draw a worse resonance structure, just for the sake of it, here's what you do. So here you have something neutral. If you want to create a charge separation, you would put the double bond on a corner like this corner or this corner at the edge. Basically, you put it on a carbon, and that will give you a negative charge on the carbon and a positive charge on something else. So for this problem, there are a few steps. So we could put this alkene on this corner, which means putting it on a carbon. That will give us a lone pair, which is just a carboanion. Okay, so then we have bromine here. But now, of course, we need a conservation of charge. Here it's neutral charge. Here we have -1, so we need a +1 somewhere. So make sure to put your carbocation here, because here there used to be 3 bonds, but now there's 2 bonds, so that must mean there's a carbocation. Okay, but now this is not complete because the bromine actually has lone pairs, which will want to attack this carbocation. So this can actually go here, and that will give you an alkene here, and putting the positive charge on the bromine. So this is the most important things you'll need to know. So to debrief, in example 1, we see how the alkene will chase after the carbocation, and the positive charge will replace the spot where the alkene once was, or the radical. And for step 2, if you want to turn the neutral thing into charge separations, you can put the alkene on a corner, which just represents a carbon, and that will give you a carboanion, and make sure to double check that your charges balance out.